Hello student, the question says the magnetic moment of an electron E revolving in an orbit around the nucleus with an orbital angular momentum is given by. So has given four options. Let us see the diagram of this. So we have an electron rotating around the nucleus. Since then, let us assume that the electron is rotating in clockwise direction. So we are assuming that the electron is rotating in clockwise direction. If the electron rotates in clockwise direction, what would be the direction of L? First, let us talk about direction of L. The direction of L would be, since it is clockwise, the direction of L would be inside. Or we can say, if I assume this is I, this is J, inside would represent minus k cap direction because I am following this coordinate. And what would be the magnitude of this? I'm only talking about magnitude. Magnitude would be m into v into r. Technically, it is mvr sine theta. Theta would be 90 degrees. So I got both magnitude and direction. Now, if you take this scenario, if electron is moving in clockwise direction, we can assume the current is flowing in anti-clockwise direction. So I can redraw this diagram as a ring where the current is flowing in counterclockwise direction. If current is flowing in counterclockwise direction, what's the direction of magnetic moment that we need to find? So the direction of the magnetic moment would be, since it is anti-clockwise direction, it would be outside. Or in this case, it would be k cap direction. I have used m to represent it, but in this problem, mu l is used to represent it, so I'll use the same rotation. What's the magnitude of this mu l? Magnitude of this mu l would be n into I into a. Here we have only one loop, so I will write q by t. A is pi into r square, where r is the radius of this. Next, let us substitute everything. So mu l equals to q by, how do you get the time period? Time period is basically time taken for one rotation. So time is nothing but distance by speed into pi r square. So I will get q into speed value is v. Distance is, in one rotation, it covers a distance of 2 pi r into pi r square. So if I solve this, I will get pi I can cancel, r we can cancel, we'll get the values qvr by 2. So I can write this as mu l equals to q by 2. We know mvr equals to L. So from this, VR is nothing but L by M. Let me just substitute it. So VR is nothing but L by M. This is magnitude wise. Then what about direction? We have seen that both have opposite direction. So how do you say this vectorially? You will say that QL is minus E by 2 into L bar by M. Again, I will repeat. Here, when I substitute Q value, I have to take not minus C, plus C only, because we are conveying the others that this is only magnitude. While taking the formulas for magnitude, we don't take plus C and minus C. We'll directly take E value only. Here we got this negative sign because we visually understood that both would be in opposite direction. UL and L would be in opposite direction, and that's how we get option B. Hope you understood how I have solved it. Thank you.